Recording now. So welcome back everybody, and we are going to go through some video stuff today, but also we are going to reach to some amazing stuff today. So let's open the studio immediately and let's get down to it so we can reach as far as possible today. So I'm going to share my screen with you now. I'm going to share my art studio with you. Share screen, IntroToR art studio share. So I hope you can see my screen now. And I'm going to create. So first, if you have multiple art projects, or if you are not certain that Art Studio opens the project you had opened before, then go to File, Recent Projects, and select this project that you created in the first lecture, and open this project. With opening the project, it will set the working directory into the right place, to this directory that you have here in files. It will set the working directory in the right place. Everything will be together here in one place, in one folder. I see that many people who start using R, they do not use projects. But please do, believe me, it is way easier to organize your work if you use projects than if you just keep everything in one project or no project at all. Now I'm going to make my R studio a little bit smaller. What am I doing wrong now? I cannot understand. My problem is that I'm a little bit stupid. I have been this since I was born. But now, okay. I hope my screen is well visible now, big enough. And what I'm going to do, I'm going to create a new R script again for today. So you can have multiple R scripts open at the same time. I'm going to create file, new file, R script. File, new file, R script. And I'm going to save it to Ctrl S. Now I am okay. I saw that my picture was stuck for a moment, but now I'm moving again. I'm going to save it with Ctrl S, and for example, I name it to third seminar. It will automatically add this .r on top of it, and then we can continue. Now, last time we ended at page 4 with the introduction to R. I am putting you the link for each case. A second. I am giving you the link for each case that you can open it again. What the hell is going on? My P cloud is failing me. Does anybody have the link to the materials that you can put into the chat?
I have it. I have. I'll put it.
Put it into the chat, please.
Yeah. Done.
Okay. Sven, don't worry. But it should actually, Sven writes that my global environment is empty. It should actually not be. So if it is empty, then go to File, Recent Projects, and select the project. There is an additional possibility that you did not save your global environment when you closed Art Studio last time, or it crashed or something like this. Then it does not save this environment. But this is not important. We are going to read the data in again, and we are going to do some don't worry about this last stuff that you had in the environment. Now, first, today I am going to show you how to get data into R. So we have by now, I am going to write this, how to get data in as a comment. So remember, to write the comment, you use hashtag, and then you can write whatever you want. So we have looked at one command how to get data in. This was read.csv, and or read.csv2. Either one usually works. If you save data from Excel, then it depends on your locale. Then it depends on your locale whether the decimal point will be point, as in English, or comma, as in some other languages. Now, to be honest, you are so international crowds that I do not have any idea how your default locales are. But then either read CSV or read CSV2 will work. For you could save file as comma separated values file from Excel, from Microsoft Excel. As we looked at last time already, actually there is this import data set. There is this import data set where you can select from text based on text reader from Excel, SPSS, SAS, or Stata. What am so for Excel files, if you want to read in Excel files, then you need package read Excel. And last time we installed it, so it's library read Excel, Control Enter to load in the library. So just to remind you that to install the library, you have to install the library once, install.library read Excel. If you have installed it already, you don't have to install it anymore. So I'm commenting it out. Otherwise, every time when I run this or all of this file, it starts to install this library again. And to read in the library, and you have to read in the library every single time when you open RStudio again. And then you can use function called library is nothing more than a bunch of functions. You can use function called read Excel, read Excel, read Excel list, or read Excel SX, whatever. You can use this and give the Excel file name .xls6, sheet is 1, range is, for example, A1 to I don't know, CD 34 or something like this. This is how to read in Excel files. Now we don't have any Excel files to show you, so I'm not going to read it in. But then there is one important library that you might need. It is Haven. I don't even know how to pronounce it correctly. And this provides you functions to read in SPSS, SAS, and Stata files. So you will see that in many cases, for example, if you are dealing with survey data, then for some reason these are saved as SPSS files almost always. You do not need it. I am just showing you now. You do not need to install this Haven package. But if you need to read in SPSS, SAS, or Stata files, then yes, Haven is the library to install and library to use. It's also, this is exactly the library that is going to be used if you import data set from SPSS, from SAS, from Stata. Can I close people mix myself? I wonder, there is just some noise in the background. There is some noise in the background, but okay, there is mute all. I hope I am not muted, but everybody else is muted now. Now, so this Haven provides functions like read SAV for SPSS, then read DTA for SATA files, and read SAS for SES files. This should keep you covered for most of the situations. How can there still be noise when I muted everyone?
Everyone are so we are not muted. So I think
Okay, mute all. Mute current and new participants. Mute all. Now everybody's muted again. So let's see how far can I go. Now, then there is a package, and right now I'm only talking to you about the possibilities. Then there is a package named foreign, and this reads in pretty much everything available in the world. So there are, I don't know, there are some, it reads Octave files, Systat files, Fox Pro or whatever it is, this old databases. This foreign provides functions to read in pretty much everything that is available under the world. What has ever been used. So it is quite common that you find some interesting file on the internet. It is in some kind of interesting format that you have never heard of, and it's quite probable that R can actually open it. R can open pretty much everything that is available. Or there are some additional packages that can open you these files. There is one package I want you to be aware of. This is Feather, and this allows you to write data frames so that you can use them in Python. And Python has similar package so that you can write straight from Python and load it in R. With all the meta information there, because when you write something in CSV files, then you know some meta information gets lost. For example, that this is a date variable. This gets lost. It reads it back, and it might read it as a character type variable again. So this Feather is something to use when you use Python and R together, and many people use Python and R together. So to send this one data frame to Python, or from Python to R, or from R to Python, you would use this Feather font. But R has much more to offer. For example, R has straight connections to many of the databases available on the internet. Now, usually I use, when I teach, I usually use package Eurostat as an example. So, but this contains European information, and there are very few of you from Europe. So I'm going to use WB stats as an example. This is World Bank datasets. So for this, and again, you do not have to do it, but I want to show you how it is done. If you want, you can do it. So for this, you have to install packages WB stats. Then when it is installed, let's see how quickly it installs for me. Then load it, library WB stats, Control Enter, and this provides you functions to search World Bank data. For example, if I want to search GDP per capita data, then I would do WB search GDP per capita, and it will return me all the data sets that mention GDP per capita in the World Bank data. Now you can also go to World Bank's this. Let me share my. Let me show you this. I'm going to share my browser now. So you can also go to let's say, let me search for World Bank data. There is data.worldbank.org, open data. And now if you find something interesting from here, for example, GDP PPP, let's see what the GDP PPP, constant international dollars. Then where does it show it now? Where is the name of this data set? Am I blind? They have changed something. There is usually name of the data set included somewhere. Well, it doesn't really matter. What matters is this, that you do not need to download this CSV. You do not need to download this CSV, but you find the name of the data set. Okay, details. You see, in this details, when I click this details here, then there is ID, NYGDP, MKTP, PPKD. I am going to copy and paste it. I'm going to copy and paste it, and I'm going to copy and paste it into my R. So, and I'm going to download it like this, that WB data, and then this ID of this data set. And you know, this World Bank data, this is just one of a lot of. So again, when it downloads it, it shows it to me in the console. I don't want it to be in the console. I want it to be in my data object. So I say, for example, this is GDP data, and I am assigning it this, and now it writes this, downloads it straight from the World Bank, writes it straight into my GDP data object. And if you do, for example, some kind of slides where you want GDP growth or whatever of countries, comparison of them, then you run this code again, and it downloads the most recent data all the time. Your graphs, your slides are always up to date. And World Bank data is just one of the many databases that is available like this. I am an economist, so I know economics related data sets. For example, World Bank, IMF, this kind of stuff. But much more is covered actually. Weather data, financial data, stocks data. You can find these specific libraries that access directly these online data sets, and you can download the data straight from R. You don't have to go and download CSV file and so on. Okay. So this was just to show you the capabilities of R, how to read in some different data sets. Now I want to go to the next topic, and the next topic right now, I am going to skip some of the pages in the handout. I am going to talk to you about logic in R and filtering data in R. Another theoretical topic before we can go to some serious stuff. So let's say you want to test if 3 is bigger than 5. You just want to know if 3 is bigger than 5. You write 3 is bigger than 5, and then you hit Control Enter, and it is false. 3 is not bigger than 5. Ovi, you had error installing the packages. Which package did you have the error in? What we are going to need today, we are going to need one library actually. This GDP, this WB stats is not so important. What we are going to definitely need is tidyverse. Kind of seems to show that cannot open the connection, that your R cannot connect to outside world. Maybe you have some kind of firewall that does not let R out. Is my picture sometimes stuck only for me or for you as well?
No, it's not stuck for us. It's fine.
Interesting. It is completely stuck every couple of seconds for me. So, but Ovi, we can check this WB stats later on. Check that you can do one thing, library tidyverse. That you have tidyverse installed. Tidyverse is actually a collection of packages. When I load this library tidyverse, then it shows that it is attaching actually ggplot, dibble, tidy, reader, purr, dplyr, stringer, forcats packages. So it is kind of a meta package that loads a lot of other packages. But we are going to use these packages today, and you absolutely need this. So 3 is bigger than 5. This was false. Let's see. 5 is bigger than is smaller than 3, and this is false again. So 3 is smaller than 5. Control Enter, and it is true. So bigger than, smaller than, this is kind of normal. So for example, 4 is smaller or equal than 4. True, yes, 4 is smaller or equal than 4. 4 is bigger or equal than 5. Control Enter, false. This is not this. But what if we want to check equality? Check equality. So you remember that this one equal sign, this was already, one equal sign is already used to give some arguments their value. So you cannot test it like this, that 4 equals 5, it will tell you error. What you need is 2 equal signs, not 1 equal sign, not 3 equal signs, 2 equal signs. So if you to test equality, 4 is equal to 5, false, it is not equal to 5. If you want to test if something is not equal to something else, then 4 bang equal 5, and this is true. So 4 exclamation mark equal 5, and for some reason the programmers usually call the exclamation mark, they call it bang. So this bang is negating stuff. It says that no, do the opposite. So this is how to test inequality. Yes, where do we use these logical operations? We are going to use them in 1 second, because right now I'm telling you this to you in theoretical terms, but let's do it practically. Let's look at how to use them practically. So please, everybody, load library tidyverse. Load library tidyverse. And also, let's read in PIAC data again. If you have PIAC data already, if you do summary PIAC and it does not tell you that that the object is not found, it's when you check the equality, you always use double equal signs. Let me get to the practical examples, then you will all understand it, because it's much easier to understand it with practical examples. So let's read in PIAC. I'm going to copy paste it into the chat in a second. Read CS3 HTTP www UTE ESEPO PIAC eng.csv. And I'm going to copy paste it to the chat. and we are going to now find what do we have here now. So let's assume we want what. First, let's get a quick overview of PIAC. So names PIAC gives us all the names of the variables we have. All the names of the variables we have. If we want to see what are the possible values inside the variables, then one command you will absolutely need to understand your data is unique. So unique PIAC $gender. You remember, I'm finding now unique values of gender variable in PIAC dataset will tell us that this can be male or female. And notice male is with big M and female is with big F. So you can view PIAC. You can view PIAC. And then you would view that, you will see that, gender can be male or female. The first line here, this is a 64-year-old male who is out of the labor force, who is living with spouse, who has children, who has secondary education. So in many cases, in many cases you want to see possible values of some variables. For example, unique PIAC dollar education gives you that the possible values for education are secondary, higher, and basic. I'm Loke, you ask if unique is the same as distinct. Yes, it is the same as distinct. Let's try. Let's try. No, it's not the same as distinct. Distinct is something else. But in general, as in English language, yes, it is distinct values. So let's assume that you want to analyze not all of the people in PIAC. There is a question: when should we use quotation marks and where not within the parentheses? And it's a good question. So if it is an object name, data object name, then there are no, actually it's not like this. Let me tell you, you will try. First you try with quotation marks, then you try without quotation marks, and one of them works. Because if I would say to you right now where it is used, then in 10 minutes I will go to a next topic, and then it would be an absolutely different way where the quotation marks will be used. In base R, you use quotation marks wherever you are trying to give an input as a string. And when it is like this is data object, education inside this data object PIAC, then you do not use the quotation marks. But later on we will see that in modern R it is not so easy. Modern R, as I told you, R is sometimes it is inconsistent. So you will try to use the quotation marks, then you will try to use without them, and one of them works.
Hi Seppo, somebody is asking for passcode for the meeting.
But didn't the link that I sent?
I don't know, like earlier Hafiz was asking and now Penina is also asking the same question.
The passcode should be inside the link. Well, I will continue now. So what does namespeak mean? Or is one other question. Namespeak shows you all the variables that are inside Piak. It is the same if you would go to the environment pane and then click on this blue triangle, and it would say that it would show you the variable names in Piak and which types these variables are. Yes, there is. Satish asked if there is an option to check names and its data type in the whole data. It would be str, structure of Piak. Structure of Piak, and now it would show you, you see, it would give you, it's a little bit terrible view. It says that first that it's data frame, with how many observations, how many variables, then the sequence ID is integer, and then shows your first values, age is integer and shows first values, and so on. Also, at one point, when you are going to do summary of Piak, then you're noticing that if you are doing summary of some data frame, then for character type, it just shows you that it is character. For the numeric, it shows you the first minimum value, maximum value, and the quartiles and mean. So, but let's assume that you want to do your analysis on only the men and not the women right now. You only care about the men. So you want to take from this data set, you want to take only men out. Who are men? Men are those whose, and I'm going to go to this Piak data set right now. Men are those whose gender is male. Yes. So I'm going to show you two ways to filter out only men. First way is the base R way. And this would be, and I want you to know this because you will see a lot of codes that uses this. And then I will show you why I would not recommend you to use this base R way of filtering out data. So base R way would be like this. I'm going to create a new data set only men. New data set only men. And I'm going to assign something into it. And what I'm going to assign is I'm going to take a subset, and subset want to know from which data frame are you going to subset to find the subset. So subset of Piak, and now you need to write the condition. And the condition would be, again, that this gender variable has to be equal, 2 equal signs, not 1 equal sign, not 3 equal signs, 2 equal signs. It has to be equal to male, consonant. How do I know that it has to be equal to male again? Because I checked unique Piak $gender. I checked that it can be either male or female, this gender variable. Male is big M, and if I would have written small m here, then it wouldn't have worked. So only men, subset Piak, gender male, control enter. And now when you look at this new data set, view only men. When you look at this new data set, then you will see that it only has men. It has 2,672 men here. So this is the base R way of subsetting data. Now, modern R is what we are doing right now, where we are entering right now. This is a tidyverse. It offers a drop-in replacement, almost drop-in replacement, and the function would now be filter. Filter Piak, gender is male, and it would do the same thing. Now, this filter command, there is one thing I haven't told you. Now, this filter comes from library dplyr. So if you have not loaded in library tidyverse or library dplyr, whichever, both of them work because library tidyverse loads in library dplyr anyway. Then this command would not work because there is a filter command in base R that would be used instead of this command from library tidyverse. Actually, okay, let me tell it to you right now. Let me tell you something about libraries. So in many cases, when you, because last time when I talked about libraries, then for some reason, I went over this. I went over this and forgot to mention you one thing about libraries. So I told you that libraries are collection of functions. Now, function names sometimes collide. For example, in base R, there is command filter, and in dplyr there is command filter. So they do absolutely different things. Dplyr is part of tidyverse, yes. So you don't need to load them both. If you load tidyverse, then you automatically load dplyr. I just wrote this dplyr here just to note that this filter comes from dplyr. To make sure that you use, so the last package that is loaded, the command names by default, the commands come from the last package that is loaded. So as I loaded the tidyverse last, the dplyr last, and now filter comes from tidyverse, it comes from dplyr. But to be absolutely certain that it comes from dplyr, and I'm going to show you later, what conflicts in packages mean and how to deal with them. To be absolutely certain that you use a filter from package dplyr, you would write it like this: dplyr : filter. And many programmers, when they use R, they use it exactly like this: dplyr : filter, or the package name : the function name. Many programmers use this. Data scientists usually don't. They don't care so much, but it might be a good practice actually. Now, this much about packages, and I am going to come back to this topic later on. But for now, why do I always say that use filter instead of subset? There is a very easy reason. So let's assume I'm going to make a small mistake. I'm going to copy this subset command here, and I'm going to make a small mistake, what I'm always making, and believe me, you will make it as well. Instead of 2 equal signs, I write a 1 equal sign. And now I do Control Enter. And you see, it doesn't tell me anything. It doesn't tell me no warning, no error, nothing. It does the command. It doesn't tell me anything. Let's look at this data set now. Let's look at this. View only men. Control Enter. First man is male, second is female, third is female, male, female, male, male, female, female, female. It didn't do anything. It didn't do anything because you wrote this 1 equal sign here. Then it didn't do anything. It did not filter out the men, but it also didn't tell you that, hey, are you an idiot? You wanted to, why are you writing only 1 equal sign here? It doesn't make sense. And you will continue with your data set. You will think that there are only males in the data set, but sometimes you do not control it. Always control it when you do something in R. Always control that everything passes the smell test. Now, let me make the same mistake with filter command. Now I am going to say filter piak, and I am removing one of the equal signs, and I am now clicking Control Enter. And look what it says: error, we detected the named input, blah, 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 blah. This usually means that you have used 1 equal sign instead of 2 equal signs. Did you mean gender is equal to male? It tells you that, hey, you are stupid, you are using 1 equal sign, please use the 2 equal sign. It does not let you make stupid mistakes. Base R in many cases lets you make very small, stupid mistakes. Modern R tries to be, it doesn't expect you to be a genius. It expects you to make mistakes and tells you when you are making a mistake. So this is why everywhere I suggest you to use modern R functions instead of the base R functions if it's possible. For example, always use filter instead of subset because it does not let you do small mistakes, basic mistakes. Now, you can add 1 equal sign didn't do anything. It didn't do anything. It didn't take a subset. It didn't tell you, it didn't even give you a warning. It didn't give you an error. It is stupid. So here you in base R with subset, you always have to do everything perfectly. With filter, you do not have. Now you can add different conditions here. So a logic, you can add either with logical AND or comma. Comma is the same as logical AND. So if you want to find males whose age is bigger than 50, then you remember we had age variable in the data set. And if you do it like this, then the only men, if you look at this data set now, it has only men whose age is bigger than 50. It filtered out only these rows where gender is male and age is bigger than 50. Now you have old men. So I can also write that it's not only men, it is old men, men whose age bigger than 50. Or what else? I don't know. Let's say we are searching for a man. We are searching for a man. What do we want from a man? We want, so gender is male. Let's say we want a man. Let's say we want a man. Let's say he has to be younger than 60, but also age has to be bigger than 30. Let's say we are interested in this kind of man. Let's say, what else do we want from a man? That his income is bigger than, let's say, I don't know, 700. What else can we say? That his health, and I know by heart these names. There is a variable health in PR. Again, what variables are in PR? Names PR will tell you. There is variable health, and this health can take values of unique PR health. It can be fair, good, very good, excellent, and poor. Ricardo, did you load in library tidyverse? Are you certain? Because for me it works. Let me see if does it is. Can you reload? Please, Rituparna, please load in tidyverse again, because I think it uses library tidyverse control enter. Load it in again and tell me if it's working. And Rituparna, you as well. And now health is equal to, let's say, excellent. Control enter. Say like this. Ricardo, is it working now? after you have loaded in tidyverse. Good. Now, exactly. This this is very easy to come, this mistake. Vitupalna, can you copy your this command as well? What you run? Not only the error message, but also the command. You see, you have only health there. You have only health, but put health is equal to excellent. Vitupalna. There is just health right now here. There. So I don't know. We have only a few ladies here, but I want to tell you, ladies, that it has never been easier to search for a man, and for men as well. If you want to search for a woman, then woman is filter peak, gender is female, and you just put in the age parameters, income parameter, health parameter. There are some other parameters that you might want to put in. Then you do Control Enter, and you find 56 women that are Ovi. Gender is male. You don't have comma after the male. Ovi, you don't have comma after the male and before the age. If you put the comma there, then it will work. Yes, we can use a column 2 times there. Now, all this is logical. All this is logical, you know, is equal to, is bigger than, is smaller than. And yes, so I got a direct message, but I'm okay. So but there are some things I want you to know more, and these are not so intuitively. These do not come so intuitively. One of them is percent in percent that I need you to know. What if you want to the health to be either excellent? Let's look at the health variable. If you write the code for women, nothing happens with Pauna for you if you Control Enter. But now look at what it is.
One question, Sipo. I think the code you have written here doesn't work. For example, women filter PX, this code, actually, I run the code a few times, but error in the filter. I don't know what's the problem.
You need this woman?
Yeah, the woman code when I run it a few times.
But it works because it doesn't say, you remember, silence is bliss. If it doesn't say anything, then it will. Let's see. I have the error. You see, it's created this women data set.
Yeah, but actually showed error with me.
I ran this women, filtering PR, gender is female, age is 60 to 30, income is 700, health is excellent. It wrote it into this women data set. And now when I click on this women, then it works. I found 56 women like this. But sometimes you see, sometimes you want not only when health is excellent, you see, but let's say unique, PIAC, health, and I want you to really now look at this, because this is one very common mistake to be made and to avoid. You see, I want women whose health is either excellent or very good. So for this, I would do it like this. I would say women is, well, let's say good health. I'm only going to find people whose health is either excellent or very good. And I'm saying filter PIAC, health, and now percent in percent and vector of values, what it has to be. Percent in percent and vector of values. Very good, comma, excellent. And now it wrote this new data set, good health, where are people who is very good or excellent health. Now, why I want to again reiterate that this percent in percent is very important. It is very important, what is it? We will make a break in 3-4 minutes. I will finish this percent in percent. It is very important operator. Is that if you look at the good health now, what data set did we get? Dimensions of good health. Then we got 1,633 rows. What you want to do intuitively is, and what I see very many people making mistakes at first, is that you write here health is equal, very good, excellent. And actually, when you run this code with 2 equal signs, then it runs. It doesn't give you an error. It does not give you a warning. But if you look at the dimensions of good health now, it is only 844 people. So what happened? What happened? And this is one stupid thing God does. If you write it like this, never write it like this. Then what it does, you remember R is reusing vectors. So it checks the first person. Is the first person's health very good? If yes, then it includes. If not, then not. Then it checks the second person. Is the second person's health excellent? Then third person, is it very good? Fourth person, excellent. Fifth person, very good, and so on. So this is something that you definitely do not want to do. You always need to have this percent in percent in this case. And you will use this percent in percent, you will use this very, very often. So try to remember this percent in percent when you do your analysis or when you are filtering data. Then couple of more things, 2 more things before we will finish this part and have a 10 minutes break. So one is, if you want to remove not available values, if you want to remove values which are not available, for example, if you view PIAC, then there is a variable living with spouse. Is the person living with somebody or not? First one is living with somebody, second one is living with somebody, third one is living, fourth one is not living with somebody, fifth one, it is not available. The person does not know if he is living with somebody or not. I would be very worried about this. I would be very worried about this situation. You should actually know if you are living with someone or not, or your significant other. But it's not available here. So what if I want to remove all the lines which are not available? Then what you tend to do automatically, you tend to do this, and this is wrong way to do it. You tend to do it like this. Filter PIAC living, what was the variable name? Filter, what was living with spouse names? Yeah, you see, I don't know, living with spouse. With spouse, you tend to write it like this: is not equal to not available. But this will not work. This will not work. It gives you, you see, it gives you 0 rows and it gives you a warning here. Use is not available to check whether expression evaluates to not available. So in this case, you always should use this is not available, living with spouse. So if you only use is not available, and I'm sorry, I know how it now, because we are using double negations. So is not available tests if this variable is not available. But if we write this bank before it, then it shows, then it leaves in those rows where it is not available, where it is available, if you understand what I mean now. So this, you very often use is not available function, but in most of the cases you negate it. You use this is not available. Oh, now let me take a quick look. This is a lot of theoretical text I have given to you now without any your terms, interestingly, but your terms will come. Don't worry about this. Not available, the move will not work here. But let's have a 10 minutes break now. I will remain here to answer any questions, or when you are in trouble, then you can share them with me. I am stopping the recording for now, for the time of our break, and we will be back in 15. When the clock hits 15, then we will be back. I'm going to repeat it for the people who are joining us on YouTube, because I forgot to put it to record again. Luckily, I noticed. So now we are going to enter into the world of modern art, the amazing and elegant way to do analysis. And in modern art, everything is different than in base art. So forget everything that you have learned until now, and we are continuing with a very different way, but more elegant way. But I needed you to know the base R as well, because many packages are following base R logic, and many new packages are following modern R logic. Modern R is mainly associated with one name, and the name is Hadley Wickham. I'm going to show you the guy in a second. Hadley Wickham. I'm going to share my screen. Yes.
Sorry, please, before you go into the modern R, I just want to ask a quick question. Your
Sure.
dollar in dollar, what does that mean?
Percent in percent, you mean?
Sorry, yeah, percent in percent. Sorry.
Okay. Let me repeat this. But let me show you the Hadley Wickham first, and then I will repeat it. Okay. I will tell you the story about modern R, and then we will actually come back to this percent in a second.
Okay, so, thank you.
So I'm going to share you my browser, and here you see this guy. He's kind of a legend in R. Whenever he's somewhere, whenever he's somewhere in the conference or something like this, you can recognize it immediately, because there are a lot of people around him and trying to take a selfie with him. He is a legendary guy in R. He's single-handedly responsible for much of the popularity of R. He is the guy who created this dplyr. He's the first 10 years ago, more than 11 years ago, he created his first package. It was a ggplot, this grammar of graphics, which we will look at in one moment. This grammar of graphics. So people called modern R for the longest time Hadleyverse, because his name is Hadley Wickham, Hadleyverse. Then he renamed it to be Tidyverse. So he is he just said that, Hadleyverse will not go. Let's call it Tidyverse. But he's a superstar in R, and he has changed the way I do data science. He has changed. If you look at my code, if I look at my code, let's say 7 years ago and now 5 years ago, and now it's totally different. And now I'm going to show you this amazing, elegant world of world of modern R in a second. We start from ggplot, then we go deeper into the deep layer and other parts of modern R. But first, let me share you again my R Studio.
Mr. Sufu just paste his name in chat. We will search JP hits.
I will write his name in chat. Hadley Wickham, and I will also write it here. So he's Hadley Wickham. He has amazing ability of work. For example, I can't understand how he can work so much. How can he do so much with his time? Now, back to this percent in percent. Okay, there was a comment that in a video yesterday, some guy was saying that if Hadley Wickham dies, what happens to tidyverse? Well, tidyverse will still be well, the future dies then. Tidyverse is the reason why I prefer R to Python. Python will have this solved, but I don't know when. In 5 years, in 3 years, I don't know when. Up until now, everything that you learned is directly doable in Python, directly comparable to Python. So if you in Python there are data frames as well, and all the logic is the same. But what we are going to learn now, this is ggplot. What we're going to learn now, this is available. Implementations of ggplot are available in Python as well, and you can easily use this knowledge about the graphing, how to do graphs in Python as well. But the deep layer, for example, is not yet available in Python, this kind of similar thing. Hadley is very much working together with people, with Python data science developers. So he's copying some of the Python ideas, Python is copying some of his ideas. But I would say that because of Hadley Wickham, R is kind of the avant-garde of data science. This is where the new things happen. This is where the wonderful things happen. And then it is everybody else is picking it up, the ideas, and implementing them there as well. But first, so again about this percent in percent. So if you want to select multiple values from a data set, for example, filter, you know that PIAC health variable in PIAC can have these values: fair, good, very good, and excellent, and poor. And you want to select people who have either poor or fair health. Then what you would do is filter PIAC, and now you say health percent in percent. So health has to be inside these values, which I'm going to give here as a vector of values. So health has to be either poor or fair. And now it selects only the rows where health is either poor or fair. It doesn't select rows where health is good, very good, excellent. So there are many cases where you need to use this percent in percent. You have to remember this, because if you would use, the worst case is that if you use this is equal, it gives you totally wrong answer. It gives you only half of the lines. Always percent in percent. But yes, Kamadul, you are right that tidyverse package is maintained by very many people right now, and there are, you know, the logic that he created first, it is taken over by very many people, and people are developing it further. But he seems to always come out to some new and better ideas, and he's a genius in this respect. That he's kind of I don't know how, but he makes everything intuitive. Whatever he touches, it will be intuitive. Now, what is unique function about? Unique shows you what are the possible values in health. So health can have a lot of values, but not lot, but it shows every distinct value in health. So health is either fair, good, very good, excellent, or poor. If I would look at unique PIAC age, for example, then it would show me a lot of numbers. These are all the ages of people. One time, all the ages of people. So unique is a very useful function. You will use it very many times. If you want to see what values are possible in some variable, you use unique. But now people, let me think, what will I do with you now? I need to share. I need to give me a second. I need to share a different screen with you, but I first have to open it. Now we are entering the world of ggplot, grammar of graphics. Now, grammar of graphics itself, it was not invented by Hadley Wickham, but Hadley Wickham made it famous. Grammar of graphics is an absolutely different way to create graphs than what you are used to. It is actually by a book. It is actually comes from a book from Leland Wickland. Leland Wickland, was it? I have it actually. Where do I have it? I don't have it in my materials or what. Leland Wilkinson, sorry, I'm an idiot. Leland Wilkinson. He wrote a book called Grammar of Graphics in 1999. And Leland Wilkinson is a very well-known statistician who for example, I think he was the creator of SPSS's graphing system, SPSS graph system. But the grammar of graphics, the logic was so well hidden there that nobody really used it. Nobody got to use it. Then came Hadley and wrote and gave the power to the people. So, but let's start with a little bit theory right now. So here is a graph. How would you? Leland Wilkinson asked, what would be the minimum number of verbs to describe this graph? How can you as compactly describe this graph as possible? And what he decided is that this graph there are geometrics on this graph. These geometrics are the things that you see. For example, this is a geometric called point. Then every geometric has aesthetics. I'm going to write them down to you soon. Geometrics and aesthetics. So aesthetics are the properties of this geometric. So the size of the point is one property. The color of the point is another property. X and Y coordinates of this point are yet another property. So there are geometrics and there are aesthetics. Now this graph actually shows you. I would show you a video right now. I don't know how can I show you a video in Zoom. I think I cannot, but I'm going to copy you a link to a video, and please after we end this class, then look at this, and then you will know from where this data comes from. Let me search for it for a moment. Now tell me who wrote. Tell me who wrote factfulness. Swedish data guy. Can I show video in Zoom? Can I share video in Zoom? Because I don't think when I when I show it on my screen, then I don't think it comes through.
So what's the problem now?
I am trying to remember a name of a guy who wrote Factfulness. Very famous Swedish. I'm an idiot. How can I? Factfulness. This guy, Rosling, Hans Rosling. So let's see if I can show you this video. I would show it to you for 4 minutes. What do you think? Pretty neat, huh? So actually, what I'm showing you, this data, comes from this very same source, this Hans Rosling's data set. What I was showing you as an example, and we are going to make this graph ourselves later, not today, but probably next time. So this guy we asked was Hans Rosling, as Charlie wrote. Yeah, unfortunately he is dead now. He died during one of my courses. Not that he was taking my course, but I was just giving a course, and then the news hit me. He's an amazing guy by himself. He was actually a medical doctor, and he helped a lot of people in Africa. Went to where nobody else went, and later started to visualize data and understanding and making this data understandable to people. His latest book, which was actually published after he died, is called Factfulness. And it talks about very much about developing world, and how little developed world sometimes understands the developing world, how wrong are the assumptions. So if you look at this graph now, you can see my graph. I hope you can see my graph. Then this graph in ggplot language is here. So what I'm telling here is that create the graph. The data set used is GDP life. This is the data frame used. X, connect AS aesthetics. Connect X to GDP per capita. Connect Y to life expectancy at birth variable. Then add geom point. Add geometrical point so that its size is connected to population and its color is connected to region, and make it a little bit transparent. Alpha is 0.5. Then add geom smooth. Geom smooth is just this blue line here, which gives you the kind of understanding that what is the expected life expectancy at every this GDP per capita level. And then the rest of it makes it a little bit trickier. So scale X continues, makes the X scale to be log scale. You see 1,000, 10,000, 100,000, it's logarithmic scale. Make labels to be dollar formats so that the dollar is here, and stuff like this. The rest of it just makes it a little bit tricky. And now we are going to look at how to create this kind of graphs. One of the main killing killer futures of R. So I worked for a long time. I worked for one of the main Estonian think tanks, which did the heavy lifting of econometric analysis. It was called Center. Is called Center. I'm still teaching through them, but my main job is not with them anymore. And there was a lot of PhDs in economics there, and they all used Stata. Stata was the standard of data analysis at this time for economists. And by now they all use R. And why they use R? They started to use R when I started to create these graphs. And they came to me and looked at how do you make these graphs? I said, well, it's easy. Can you make these graphs for our applications as well? Yes, I can. Later on, they said that no, we have to learn it ourselves, and by now they all use R. But it all started with this ggplot library. Now let us create our first ggplot graph ourselves, and let me explain you the way ggplot works while creating this graph. First, just write it with me, and later I will tell you what we are doing. So first, let's write. Can you? Oh, give me a second. I am doing something wrong now. I'm going to share this again. Can you still hear me?
Yeah.
You can hear me.
Yeah.
Good. So I'm going to create the graph with you, and I'm going to start with this and do it with me. ggplot, or if you can do it with me, of course, if you have two screens or something. ggplot data is PARC. AES and parentheses. X is connected to, let's say what variable can I connect it to? For example, numeracy. Y is connected to income plus, and next line, geom point content. It's showing some. Can you also see some W in the middle of my, well, you should see. Very interesting. Well, then I don't like it. Let's try. So, did you get the graph as well? Did you manage to create the graph? I will tell you what is IS in a second. When I don't, so it's in the parentheses here. It's everything is incorrect parentheses. But let me continue. So let me tell you what I did right now. Let me tell you first what I did. I said, what did I do? I said that let's create a ggplot graph. So that let's use data, which is PARC. And now inside this IS, I said that let's X be connected to numeracy and Y connected to income, and then geom point. Now let me show you what IS means. First, let me show. I will show it in a second. So first, IS means aesthetics. Aesthetics means properties, aesthetic properties. So it is written like this: aesthetic properties. If you want to know what kind of properties a point can have, then question mark and geom point. Question mark and geom point, and what it will tell you when you go down from this help file, it will tell you, you see this aesthetics. Geom point understands the following aesthetics. Required aesthetics are in bold: X, Y, alpha, color, fill, group, shape, size, stroke. So these are the properties that point can have. For example, I can write inside this geom point, I can write that color, it understands color, is red. Control Enter, and the points are red. But I can connect this color parameter to something in the data, to some variable in the data. But if I'm connecting this color parameter to some variable in the data, then I need to do it inside AES. So I write now AES and parenthesis, and color is gender. Yes, Sapia, exactly. Color is gender, and it says a gender not found because gender was with small g. And now you see females are colored red and males are colored blue. Every point here is one person. It shows their income and their numeracy level. The numeracy shows how good they are in mathematics. So now the color is connected to gender variable. So if you set something, if you set something outside of AES, then you can tell it, for example, alpha is 0.5. Now the points are transparent a little bit. Alpha shows the transparency. Or you say that shape is 21. Now the point shape is like this. Now the point shape is like this. This is point shape number 21. But you can also connect this shape to some variable in the data set. And to do this, you would say inside this AES that shape is connecting to, for example, health. And now you see, you can see you can see every point has different shape based on the health. So if it is a point, a ring, it is excellent health. If it is a triangle, it is fair health. If it is a square, it is good health. So this is a person who is a male with good health, who earns something like 5,500 euros a month, and whose numeracy level is something like 375. So this is the basics of ggplot. You add geometrics and you add aesthetics. You connect aesthetics to the geometrics. This is a different way to think about graphs. But the moment you get it, the moment you start understanding the ggplot logic, and I promise you, you will understand this logic during this and next lecture, you will only want to make graphs like this. You will see. Yes, you can put. So let me talk to you about everything that is in this ggplot code. Everything is considered to be in this geom point code. So it is kind of it is called inheritance. So I can actually write this ggplot. I can take this out and put everything into this geom point code. I said after AES, I said comma, alpha is 0.5, and now it makes the points translucent. So everything we will get to the pipe operators. No, you can't. No, you can't. Is a short answer. Not, at least not always. I think you can't. I think it will make.
One question: what's a function of plus sign after the brackets?
Because this is all one line. Actually, not one line, but this is all one. The plus means that it all comes. It's all together. It is all one code block.
Okay, that's clear now.
You build the ggplot one by layers. You can add different layers. For example, if I want to add now If I want to add the next layer to it, then I would add plus.
Is
and
it like a
geom,
concatenation?
something like this, just.
Yeah, okay.
For example, geom smooth. Let's see what geom smooth does here. First of all, it does nothing because it requires data. It requires state. You see, everything that is in this ggplot is by default in the next lines. So
Yeah.
now I have to write again. Data is peak, AES, X is numeracy, Y is income. Then he knows how to write this smooth line, and the smooth line, smoother. This is how to explain what it is, and somebody maybe help me.
Yeah, it's like a fitting curve, like a smoothing line.
It's a fitting curve, yes, it's fitting curve, but how to say, it's fitting curve. It shows you the expected income on different numeracy levels. So if you do not know anything else about these people, then this is the, for example, if someone's numeracy level is 400, then the best bet you can make is that their income is just below 2,000 euros. It is your best bet. You see that the actual incomes are very different, but the average, this conditional mean is this. It
So
shows
like
you how two variables are connected to each other.
no,
You see
so
that
like,
it grows. This means that if numeracy grows, the income grows on average.
yeah, perfect.
So Rituparna, you asked what does blank parentheses mean? It's just this ggplot is a function. Function always have parentheses. Now I'm going to write this. I'm going to copy this AES again into this ggplot here in the top line, and leave. Okay, let me write it again. Let me just write it again because I don't know. So again, so ggplot data is peak, AES, X is numeracy, Y is income. This means if it is in this ggplot call that every aesthetic that is below it has these as default, but you can overwrite them. Plus geom point, let's say just geom point. Now let's add plus geom smooth. Now it shows that. Now it shows you the connection between numeracy and income. But if you look at the help file of geom smooth, question mark and geom smooth, then what you see is that it has again some aesthetics. Again, some aesthetics X, Y, it requires X and Y, it cannot do this line. It's also called, it is called non-parametric regression line. But the intuition is that it gives you the best possible, if you only know person's numeracy level, then this is the best guess for their income. The real incomes are very different, but this is best guess for their income. So geom smooth also can take color. Let's see what happens when we set, for example, when we connect color with gender variable inside the data set PI. Control enter. And you see what happens. It creates you two different lines, one for women, one for male. And you can immediately see what's going on in your data. Hey, at every numeracy level, men earn more in Estonia than females earn. It shows you immediately that yes, for both females and males, the smarter you are, the more you earn. But at every level, for example, if the numeracy level is 300, then for women the wage is something like 900. The wage for men who was as smart as the same smartness, it is over 1,000. Sorry, yes. It is getting interesting. Of course, it is getting interesting, and that's the most interesting moment in 5 minutes. We are going to stop. So, but for 5 more minutes, I am going to keep you here. Ooh. So let's actually. So I'm going to show you. I'm going to get it. Yes, we will go into details in next week. But I'm going to show you one more thing. Now, let's remove these geom points totally. Let's remove the points and only leave the geom smooth here. I'm removing the points and only leaving these. Don't worry about the warning messages. The warning messages show that there was missing data in the data set. Of course there was. You could not, but it still writes the code. Now it only shows the regression, the nonlinear regression lines. And you can see that, you know, men are at every, however smart you are, men are the same, men with same smartness as women are earning more than women in Estonia. Now, what if we want to see what is the effect of education? Then what you would do is this facet wrap and now tilde education. And you have the same graph. You have the same graph showing you these lines for different education level, for basic education level, for higher education level, and for secondary education level. So you can immediately you know, how to say it now, you can see the file in different, see the data in different dimensions. You can see in many different dimensions what the data is telling you. For example, you can see that for higher education level, it is growing quicker, this line. This means that if you are smart, then education pays more. If you only have some basic education, okay, the gray area here shows the confidence interval. So you don't actually know where the line is. Somewhere in this confidence intervals, you have very few people with basic education, so you cannot really visualize this well. You cannot find the correct line here. But let me remove the gender here for a moment, then you can maybe see it better. So on average, if you are having secondary education, then yes, you will earn more if you are smarter. But if you have higher education, then you earn much more when you are smarter. Oh, this is the basics of. I just removed the geom point line. So there was a geom point line here, plus this, and I removed it. I commented it out, for example, then the points are gone. I'm sorry I went a little bit quickly at the end because I wanted to give you the basics of ggplot before we end this lecture. We will go back to it. I think tomorrow. I will discuss it in a second. But first, there is your turn on page 16. It is a little bit too hard, actually. It is a little bit too hard, but you can try it. You can try it at home. Your turn at page 16. Don't worry at all if you will not make it, because I have not taught you this well enough. But I'm going to stop the sharing right now. I'm going to. Thank you, Apia, for helping me here. I am going to end the official part right now.